Hi everyone. So today this is part 2 of solving literal equations with multiple variables and proportions. So yesterday we isolated variables of literal equations, and literal equations are really just equations that we're solving for a variable instead of for a numerical value. So today we're going to look at proportions. And I do like to think of proportions like what we do to clear fractions, but what's a proportion? A proportion is an equation that involves I typo right there, two equal ratios. And a ratio is just a comparison of two numbers. Now, you sometimes are used to seeing ratios written like this, 1 to 2, but it can also be written as a fraction. So that is actually comparing numbers 1 and 2. So let's look at how we might solve a literal equation that involves a proportion. And I follow a kind of specific method. Okay, this isn't the only way to do this. This isn't the only terminology to use, but I'm trying to make this easy for now, and we can turn it into something a little bit more mathematical a little bit later. Okay, all right. So on the left we have a linear equation: x over 3 equals 9. And sometimes that looks funny to us. So what I like to say is, because I have a fraction equaling a number, let's get that into what I call proportion structure. Proportion structure is just a way to make it so that you see it a little bit clearer. So I would rewrite this as x over 3 equals 9 over 1. So now I actually have a proportion, or it's clear that I have a proportion. Now, to solve a proportion, you multiply both sides by the lowest common denominator, or in this case 3, and some teachers might say cross multiply. So we are going to multiply x times 1 and then 9 times 3, and we're going to get x times 1 is x equals 9 times 3, which is 27. The same thing can be done with a literal equation. So first we want to put it into the proportion structure. We want to recognize that y can be written over 1. So x over 3 equals y over 1. We multiply both sides by 3, okay, or we cross multiply. And we get x equals 3y. And there we go. Okay. Harder when I've got some variables, expressions on each side. So these I only had x over 3, a monomial, or like a fraction with a variable. But here now I've got it added by 1. So I still can put 2x minus 1 into proportion structure. So this, I want you to think about this, because normally you guys want to add 1. You might even choose to clear fractions. But let's use this idea of proportion structure to see if that might help us. So first, I'm going to put it into proportion structure, which means I'm going to write one side of the equation over 1. In this case, it's going to be the left side, so I'm going to do 2x minus 1 over 1 equals 3 over 2. Then I'm going to clear fractions by multiplying by the lowest common denominator, or I'm going to cross multiply. Now, you got to be careful when you cross multiply, which is why I don't love the word so much. When you're multiplying 2 times 2x minus 1, it's an expression, so it really belongs in parentheses when you multiply. So 2 times 2x minus 1 equals 3. All right, now we distribute our 2, and we get 4x minus 2 equals 3. You can see now why those parentheses were important. And then we're going to add 2. And we get 4x equals 5, and then we divide by 4. So x equals 5 over 4. Okay, so remember, that's a linear equation where we solve for a variable. Now we're going to solve for x when we have another variable in it, so a literal equation. Okay, so I'm going to write it in proportion structure, which means I'm going to put both sides over, make them fractions. So I'm going to write x over 2 equals m minus 6 over 1. Then I'm going to multiply both sides by 2, or cross multiply. So I'm going to use both methods here. I'm going to use multiply both sides by 2 would be like if we cleared fractions, which is the nice way of saying. So the 2's on this side would cancel, and you'd get x equals 2 times m minus 6. Now we distribute our 2, and get x equals 2m minus 12. If I did that same thing and cross-multiplied, you're going to see I'm going to get the exact same thing. So both methods, they're the same thing, but one's a little bit more mathematical in their terminology. So we'd get x equals 2 times m minus 6 and go from there. So x equals 2m minus 12. All right, let's make it a little bit harder. A little bit harder is when I give you a linear equation with a fraction outside those parentheses. Now, we've actually worked with these. Sometimes you end up distributing them. Sometimes I've asked you to multiply both sides by the reciprocal, but you can't clear fractions because there's parentheses. But another way to do this is actually to use a proportion. So first we have to get it into proportion structure. So this is a little funky, so watch and be very careful. So I would write 10 over 1 equals, this expression has to go in the numerator. So it would be 2 times x minus 4 over 3. So now I have a proportion. This is actually a really nice way to solve this equation. So now I can multiply both sides by 3, okay, or cross multiply. And I get 2 times x minus 4 equals 30. And then I can divide both sides by 2 because it's being multiplied. So I get x minus 4 equals 15, and then I add 4. So x equals 19. Okay, but a literal equation, a little bit harder because I've got two variables. It's the same process. First, we're going to write it in proportion structure. So I'm going to put d over 1 equals 11 times x minus 15 all over 5. All right, then I'm going to cross multiply. So we get 5d equals 11 times x minus 15. Now we really don't want to distribute here. 11 is being multiplied to the whole quantity, so we can divide it. So divide by 11 on both sides. So I get 5d over 11 equals x minus 15. Again, we're solving for x, so we're going to add the 15 to the other side. So 5d over 11 plus 15 equals x. And there I have solved a variable. I've solved for x in terms of d. Okay. All right. Where do we see this? Again, we use these types of proportions and we apply them in real life. A lot of the times we use literal equations in science. So the formula to convert Celsius to Fahrenheit is given by the equation or the formula C equals 5/9 F minus 32. Solve this formula for F. Okay, so right now I can calculate the Celsius if I'm given the Fahrenheit. I'm trying to solve for F where I can find the Fahrenheit given the Celsius. And that's why literal equations can be cool to work with. So first, proportion structure. Make sure we put the parentheses in the top. And now we cross multiply. Proportions are beautiful. And remember, I'm saying cross multiply, but what we're doing is multiplying both sides by the lowest common denominator. We're multiplying both sides by 9. But, okay, so we're cross multiplying here. And we get 9c equals 5 times f minus 32. Okay, so now I'm gonna, because 5 is being multiplied to that quantity, I'm gonna divide by 5. So now I have 9/5 c equals f minus 32. And then I'm gonna add 32 to both sides. Okay, so 9/5 of the Celsius plus 32 degrees is going to give me my Fahrenheit. And that's what that new literal equation has given me. All right, guys, hopefully that was helpful. Another way to solve literal equations. And we'll be working on this in class tomorrow. So have a great day.